We want to solve z cubed minus 3z squared plus 3z minus 1 is equal to 0. We're going to start by looking for a linear factor of the left-hand side using the factor theorem. With the 1 at this end, we only really need to worry about f of 1 or f of negative 1. So we'll let f of z be equal to z cubed minus 3z squared plus 3z take away 1. And let's try f of 1. That's 1 take away 3, add 3 take away 1, which is 0, which tells us that z minus 1 is a factor. So, z cubed minus 3z squared plus 3z take away 1 is equal to z minus 1 multiplied by a quadratic factor. With the z cubed at this end, it must start with z squared. With the negative 1 at this end, it must end in a plus 1. And we don't know what's in the middle, so we'll write plus az. We can find a by looking at coefficients of z squared. On the left-hand side, we have negative 3. What gives us a z squared on the right-hand side? Well, we're going to get negative 1 from there and plus a from there. So that gives me that a is negative 2. So what we now have is z minus 1, z squared minus 2z plus 1 is equal to 0. And that gives me z minus 1 all cubed equals 0, which only has, that's because this bracket is z minus 1 all squared. And so we only get the one solution, z equals 1. You might think of that as being 3 coincident roots, 1, 1, and 1.